Okay, so this is the last problem from the third problem set, David Tong's lecture notes. So this one we're just asked to try to quantize the Dirac field, assuming the field obeys a canonical commutation relation rather than anti-commutation relation. And the first thing is to, prove that assuming our operators satisfy a canonical commutation relation, then that this commutation relation will work out. So I've already done this, the right way with the anti-commutation relation, and it basically works out. The calculation is exactly the same. In fact, I've just copied it over and then replaced all the anti-commutators with commutators. So there's not much to say about it because it really works out in exactly the same way. But then the other thing, so again, all the steps leading up to forming the normal ordered Hamiltonian up to this step is exactly the same. There's no difference, so I've already shown that. But once you get to this step, where the correct thing when we have canonical anti-commutation relations, you would anti-commute these two things, so you'd get a plus sign. But in this case, if we say there are canonical commutation relations, that minus sign doesn't go away. So when we normal order things, it's this. And the problem with this is if we compute the commutator of the Hamiltonian with our C dagger, we get this. And we can use that to prove that the energy of our states with C particles they have negative energy. So we could keep creating C particles to get to lower and lower states, which doesn't make any sense, which is the whole point and why we say this theory doesn't make any sense, and that instead we should use canonical anti-commutation relations for our Dirac fields.